Abdullah.
Yes, sir.
So today we are going to start a new chapter, that is light, reflection and refraction. Okay. Mhm. Abdullah, do you have any doubt in the previous chapter?
No, no, sir.
Okay. Wait a minute, we will just start. So just to start the chapter, we are going to start a chapter that is light, a reflection and a refraction. So first of all, I'm going to define what is light. So light is basically a form of energy which enables us to see the objects around us. So we can define it as light is a form of energy that enables us to see the object, to see the object around us. So what is light? Light is a form of energy which enables us to see the object around us. Basically, whatever we see is a form of energy that enables us to see the object or the substance or anything around us. That is light. So in light, I'm going to write the characteristics of light. So characteristics of light, write topic, characteristics of light. Wait a minute. Now see characteristics of light, we can write light travels in a straight line. Light travels in a straight line. So basically light travels in a straight line, also known as rectilinear propagation of light. Rectilinear propagation rectilinear propagation of light. So you should see light cannot travel by bending its ways. It will always travel in a straight line. That property is called rectilinear propagation of light. Is that clear, Sir?
Yes, sir.
Now see, speed of light in air. In vacuum, you can call it in vacuum. And also basically we take almost equals to in air equals to 3 into 10 raised to the power 8 meter per second. This is the speed of light, highest of anything. So write these two properties of light or characteristics of light, which is very important. Your syllabus is up to reflection, right?
Yes, reflection.
Okay, please write it, note it down, and if you're done with this, let me know.
Sir, I did.
Very good. Now, going for another topic, which is a reflection of light. reflection of light. We can have a number of definitions of a reflection of light, but we need to understand the concept behind reflection of light. So first of all, I'm going to write a small definition. So basically, what is reflection of light?
The bouncing back of light is called as
Bouncing back of light. Very good. Bouncing back of light. Bouncing back of light is called reflection of light. Or a big definition we can elaborate this definition like when a ray approaches a smooth polished surface and light ray bounce back or bounces back, this phenomenon is called a reflection of light. A reflection of light. There is condition for reflection of light. If you are going to incident, that means the coming rays, if you are going to incident a ray on a wall, it won't be reflected. But if you are going to incident a ray that is polished on a polished surface, it will bounce back, and that phenomena is known as reflection of light. Is that clear?
yes, sir.
So see, there are two types of reflection. The one is regular reflection. The one is regular reflection, and the another is irregular reflection. Irregular reflection. So what is regular reflection and irregular reflection? I'm going to explain it, but first you are going to write it, note it down, and let me know if you are done with this.
Sir, I noted down.
Very good. So see, what is regular reflection? Basically, regular reflection comes from a smooth surface. It comes from a smooth or even surface. Even surface.
Sir,
Or
what is
this
the
comes from
definition again?
what you just asked.
Again, what is regular reflection?
Regular reflection is the reflection from a smooth or even surface, like if you have polished surface like this, polished surface, you will have a regular reflection. This is incident ray. This is reflected ray. Again, if you are going to incident ray, this is incident ray. This is reflected ray. This is incident ray. This is reflected ray. But if you have uneven surface like this is uneven surface. So if you are going to see, this is like this. This is like this. Are you getting my point? The reflected ray will have different direction, but this you can see they are parallel to each other, yes or no? But this will not they will not be parallel. Are you getting my point, Sa?
Yes, sir.
So this is the difference between a smooth and uh, regular reflection and irregular reflection. Are you getting my point?
Yes, sir.
So please write it. Are you done with this?
Sir, one. Yes, sir, finished. Sir, finished.
Very good, very good. Now see, laws of reflection is very important. Before laws of reflection, oh yes, I'm going to write it down. Laws of reflection. There are two laws of reflection. Do you know about it?
Yeah, sir. The incident ray and the reflected ray, and one more is they all lie in the same line, like something like that.
One more. That one more is called. What is the name of one more?
It is called as
Normal.
yeah, normal.
So basically, the first point I'm going to write the angle of incidence. The angle of incidence. I'm going to write what is angle of incidence and all is equal to the angle of reflex is equal to the angle of reflection. That means angle I will always be equal to angle R. This is the laws of first law of reflection. The second law, as you stated, that the incident ray, the reflected ray, and the normal all lie in the same plane. The incident ray, the reflected ray, and the normal at the point of incidence and the reflected ray all lie in the same plane. So these are two definite laws of reflection. See, this is basically mirror, and if you are going to incident a ray, it will go like this. This is reflected. This is called incident ray. This is called a reflected ray. A reflected ray, and also this is the basically normal. That means perpendicular 90 degree. And see the angle between incident ray and normal, n for normal. The angle between incident ray and normal is called angle of incidence, and the angle between reflected ray and normal is called angle of reflection. And according to the law, this angle will always be equal to this angle. Are you getting my point?
Sir, can you explain one more time?
See, if you have a question, what is incident ray? Incident angle, incidence, angle of incidence or angle of reflection. So the angle between incident ray and normal is called angle of incidence.
Yes, sir.
Angle of incidence. That means this the angle between this point, this line and this line. This line is called incident ray, and this line is called normal. And second, we can write the angle between reflected ray and normal is called angle of reflex. Is called angle of reflex. So these are two definitions for the angle of incidence and angle of reflection. It is important to note it down, and also always remember this angle is called grazing angle. This angle is called grazing angle. What is grazing angle? The angle between incident ray and the surface of the mirror is called grazing angle. Are you getting my point? The grazing angle is the angle between incident ray and the mirror surface is called grazing angle.
Sir, but I'm writing those 2 points.
Okay, just write it. Are you done?
Yes, sir, finished.
Very good. Now see, basically what I was trying to explain to you after incident angle and incident or reflected angle. Uh, you can see this is basically mirror, and this is incident ray, this is reflected ray, and this is north. This is north. This angle is called incident angle. This angle is called reflected angle. And in some books, it is also written that this angle. What is this angle? Basically,
Angle.
angle between either incident ray or reflected angle between incident ray and mirror surface of the mirror. This uh, mirror surface mirror surface is called grazing angle.
Sir, I wrote
Grazing
this.
angle.
I wrote this.
And also, very good. And also you can write the angle between reflected ray and mirror surface. Reflected ray and mirror surface is also called grazing angle. Are you getting my point?
Yes, sir. I got it.
Now see, do you know what does this perpendicular means? What does this perpendicular means? That means this is incident ray and the reflected ray, and this is normal. Normal is basically this is 90 degree. Are you getting my point? Normal means perpendicular, that means it is 90 degree.
Sir.
Are you getting my point? This normal stand for 90 degree.
Yes, okay, sir.
Now see, if this angle is I, then this angle will be, you know that this the whole angle is 90 degree. Okay.
Yes.
And if this is I given, and let's say it is x, I 90 degree will be equal to I plus x. Yes or no?
90 degrees goes to I plus x. Yes.
So x you can easily find out. 90 minus
Yes,
I.
if we get y, we know y.
We know why.
No, if we know I, we can
Yeah, yeah.
get x.
We can easily get this. Okay. So please write it and write a question with me. If you are done with this.
Yes, sir. Finished. I finished that.
Hmm. Okay. So see, this is incident. If I'm going to give you this 35 degree, calculate angle X, Y, and angle Z. Can you calculate it?
Sir, again?
If this angle is given 35 degree, can you calculate X, Y, and Z?
Okay, sir. Okay.
Are you done with this?
Sir, 1 minute. 1 minute.
Okay, please solve it.
Sir, I got the answer.
What is the answer?
Sir, x is equals to 35 because incident rays equals to reflected ray, and y is
Not
equals.
incident ray. Angle of incidence is equal to angle of reflection.
Oh yeah,
Second, you have used this wrong. Okay.
yeah, okay. It is because they both are equal, and y is equals to 55.
55. Why 55? Because we know that this angle is basically 90 degree. So 35 plus y, 35 degree plus y will be equal to 90 degree. So y will be equal to 90 minus 35, which means 5, and then 8 minus 3 will be 55. So y is 55 degree. In the same way, z will also be 55 degree. Is that clear?
Yes, yes, sir.
Okay. Now I'm going to give you another question. This question is quite good. Here is a mirror. Here is another mirror. And here is another mirror. Now you have a question like this. This is incident radius, incident ray. This is reflected ray. For reflected ray for this mirror, but this will be incident ray for this mirror. Are you getting my point?
Yes, yes.
This is incident ray. This is incident ray for this mirror. This is reflected ray for this mirror. But for this mirror, this is incident ray, and then again reflected ray. And this reflected ray is incident ray for this mirror, and this is a reflected ray. Are you getting my point? So basically, this is like this is like this, and this is like this. Now I'm going to give you only one degree, that is, this is basically 50 degree. Calculate x, y, z, a, b, c, d, e, f, g. So please note it down and try to solve it. I'm waiting.
Okay, sir. Sir,
Yes.
can you give me one clue how to find A? Just one clue. After I find Y, how to find A?
A.
Just one clue. A. A.
See. Are you done with x?
Yes, I have done X and Y as well.
X is 40 degree, right?
Yes, 40.
And y is 40 degree.
Yes.
This normal is parallel to this mirror. Yes or no?
Yes.
Alternate interior angle, y or z.
Yeah. Oh, okay. Okay, sir, I'll do it.
Alternate interior angle. Okay.
Okay, sir. Sir, I got the answers.
Okay. Let me know the value of Z, that is 40 degree, yes.
Yes, 40 degrees. A is equals to
And
50.
A is 50 degree. A is
B is
50
equals to
degree.
50. Yes.
B is 50 degree. C
C
is
is 40
40
degrees.
degree.
D is
D is
equals to
40
40.
degree.
Yes. D is equals to 50 degrees.
Yes. And E is 40 degree, then F is 40 degree, and this is
Yes.
50 degree. Are you done with this?
Yes, sir.
Okay, very good. So do you have problem in this finding grazing angle or incident angle or reflected angle? Abdullah,
Yes, sir.
so do you have any doubt in this?
No, sir.
Okay. Now moving to the next topic, that is spherical mirrors. A spherical mirror is basically of two types. The first one is concave mirror. You have already studied about it. And the second one is convex mirror. So before writing the diagram of concave or convex, I am going to define it. A spherical mirror whose reflecting surface is curved inwards, is called concave mirror. There is a spherical mirror. You can see this is the spherical mirror, and if you are going to cut it in two pieces and and you just polished the back, and the spherical the reflecting portion is curved inward, the reflecting surface is curved inward, is called concave mirror, and the reflecting surface is curved outward, is called convex mirror. So I'm going to write the definition of this convex also. A spherical mirror whose reflecting surface is curved outward, that is called convex mirror. So this is the difference between concave and convex mirror. You have a spherical mirror and you just cut it down, and if you are going to polish the outward surface, and if the reflecting surface is curved inward, that is called concave mirror, and if you have the reflecting surface curved outward, that is called convex mirror. So basically curved outward, this is reflecting surface, so basically this is convex mirror, and this is reflecting surface that is curved inward, that is called this is reflecting surface, this is called concave mirror. Are you getting my point?
Yes, sir.
Okay, please write it.
Sir, finished.
Finished, very good. Now see, there are some definitions regarding this. If you have concave mirror, that means the outward part is polished and the reflecting surface is curved inward, and this is basically principal axis. Have you studied about it?
Yes.
This is principal axis. And you know what is center of curvature or radius of curvature? If this is a spherical mirror, and if it is a spherical in shape, you know that it will have radius. This is center, then it will have radius, right?
Yeah.
So if you are going to cut it from here and going to just polished outer surface, so this point, just suppose this is center of curvature, also known as radius of curvature. So basically this spherical or concave mirror comes from this point, this surface, this diagram. So this is radius of curvature, or this is known as radius of curvature. And this point is known as center of curvature. This point is known as center of curvature. And then again, another definition comes, another term, that is focus. And how we got focus, we will discuss about it. And the midpoint of this C, and this is called, what is this called? Pole, yes or no?
Yes.
This is called pole. So see, what I want to say is that the midpoint of this point will be F, and this F is called focus, and this F is called focus. So how we got focus is basically when we incident some light, it will go like this, incident, and the reflected ray pass through a point. That point is called focus. That point is called focus. When when incident rays go and reflect from a concave mirror, it will pass through a point on principal axis. That point is called focus, and the distance between focus and pole is called, tell me what it is called? Focal length.
Focal.
What it is called? Focal length. So basically this is focal length, and this radius, the distance between, you have to write it clearly, distance between center of curvature and pole is called radius of curvature, is called radius of curvature. So this is 2 point which is very important. First of all, you have to note it down that when image formation takes place, there will be principal axis and then focus and then center of curvature. The distance between center of curvature and pole is radius of curvature. The distance between focus and pole is called focal length. And this focus of also one more point which is very important, focus of concave mirror. Focus of concave mirror is called real focus, is called real focus. Please write it down. Then we will talk about convex and then see what happens there.
Sir, again, what is center of curvature?
Center of curvature is this point. Basically, it comes from this sphere. This sphere has a center, and the distance between center and any this endpoint of this circle, sphere, that is radius. So basically, this center is called center of curvature. If you have a spherical mirror and just you are going to cut it in two equal parts, the point of center is called center of curvature.
So,
Are you
sir,
getting my point?
yes, sir. Sir, so sir, between CP is radius, right?
Radius of curvature. It is called radius of curvature.
Okay.
The distance between center of curvature, and pole is called radius of curvature.
Okay, sir.
Also, a relation between focal length and radius of curvature. Also, a relation between focal length and radius of curvature. Always remember, since I told you focus is the midpoint of C and P, so a radius of curvature is equal to 2f, or focal length is the midpoint, so it will be r by 2. Are you getting my point? So
Yes,
this
sir.
is the relation between focal length and focal length. Basically, write a small f, because capital F I denoted for focus. So 2f, or f is equal to r by 2. Please write it and let me know. Are you done with this?
Sir,
Abdullah, you are
yes, sir.
not audible.
Finished.
Okay.
Finished.
Now see, from convex mirror, we are going to conclude all these parts that we covered here, so we can easily understand. See, this is basically convex mirror, and you have a principal axis as similar as to in concave mirror principal axis, and it has center of curvature as well. But see, if rays comes from this way, it will reflect like this. It will reflect like this, yes or no?
Yes, yes, sir.
But it will appears to meet at a point that is called focus. This is
Focus.
pole, that is called focus, and it will have a point that is called center of curvature. That is called center of curvature. So see, this focus is virtual focus. This is known as virtual focus, because rays are not actually meet, they appears to meet each other. This distance is known as focal length. This distance is known as radius of curvature. Radius of curvature. So if you have studied about it, so you should know about it. You know about it that from convex mirror we get virtual image. From concave mirror we get real image. This is the difference between virtual and real image. In real image, rays actually mix, then formation of images by the actual meeting of rays is called real image, and the formation of images by the rays appears to meet, that type of image is called virtual image. Okay, Abdullah?
Okay, sir. Okay. Sir, 1 minute, just 1 minute.
Yes, please write it. And image formation, basically, we will definitely do in the next class. And if when is your paper? I was about to ask about the paper.
My science paper is next week at Wednesday.
Wednesday next week. Okay, we have 2 classes. We can easily complete. Apart from this, which chemistry chapters is coming?
Only one, the reaction.
The first chapter
Yes.
that we already covered. So that means
Yes.
in the next class we will cover all the syllabus of your up to reflection. So there won't be any problem in that. Do you have any doubt in this?
No, sir.
Okay. So please read about image formation by lens. I'm going images of two types, basically. Images of two types. One is real image, and the second one is virtual
Virtual.
image. They are very easy. Virtual image. Virtual image is how image formation take place. So when more than two, or when two or more than two rays meet each other, image formation take place. When two or more rays meet or appears to meet, then image form. So this is it basically. After this, we will discuss in the next class real image, virtual image, and image formation by concave mirror and convex mirror, which are very important. Okay, up to reflection, your syllabus is up to reflection, right? Abdullah.
Yes, sir, till reflection only, not refraction.
Okay.